Hey there, class. Mr. Plusky here. Hope you're having a good day so far. We're continuing with Chapter 9. This is 9.6, which is solving rational equations. And we're going to be checking for extraneous solutions as well for some of these. All right. Solving rational equations is going to be very similar to solving other equations, except we're doing what's called fraction busting. We talked about fraction busting earlier in the year, I think. But basically, we're going to be finding a common denominator, or least common denominator, and then we're going to be multiplying by that least common denominator, and that will eliminate all the fractions in the bottom, and it will kind of make it a nice equation that we know how to solve without any weird stuff to deal with, okay? So let's get right into it here. Here's the steps. The steps are to first factor the denominators if necessary, because if you just multiply by everything in the denominator, you might be multiplying by repeated factors, so you want to make sure that you're multiplying by the least common denominator, not just any denominator, okay? Then we're going to find the LCD, least common denominator, which is the least common multiple. Then we're going to go ahead and multiply. We're going to multiply both sides of the equation by the LCD, and this will clear all fractions. Then we're going to solve the equation, and then we're going to check for extraneous solutions. And I would just plug, when I'm checking for extraneous solutions, I would not write out every single step, because you're going to get some weird fractions here for some answers, and it's going to be kind of hard to plug in here and there. So I would just use a calculator and simplify as best you can, and just show that like 15 equals 15, or -7 equals -3 would be not a solution, something like that, okay? All right, let's get through a couple examples here. So we have 5x over x minus 1 plus 5 equals 15 over x minus 1. So first thing we need to do is factor if we are able to. Do we need to factor the denominator of any of these, or no? We do not. We don't have any like x squared minus 4 or something like that. So now we need to find the least common denominator. So the least common denominator is going to be, we need to make sure that every factor in the denominator is multiplied here. So we only have one denominator here, which is what? It's x minus 1. That's going to be our least common denominator. But if there was like this was over 4, we'd have to do like times 4. Well, yeah, you won't be able to see that. If there was a 4 underneath the 5, for example, you'd have to do 4 times x minus 1 would be your least common denominator. Or if there's an x under 5, it'd be x times x minus 1. Okay? All right, let's do this now. So now next step we need to do is we're going to multiply all the terms by the least common denominator, which is x minus 1. So I'm going to multiply. So we have 5x over x minus 1. It's going to be multiplied by x minus 1. Plus, we are going to do x minus 1 times 5. I'll put these all over 1 for now. It makes things a lot easier. Then we're going to do 15 over x minus 1 times x minus 1 over 1. All right, so now we can go ahead, we can multiply everything by x minus 1. So nice thing about like 5x over x minus 1 times x minus 1, these are going to cancel. And same thing over here, these are going to cancel. And then we're just going to have 5x. But then we have to multiply 5 by x and by -1. We need to distribute here. So 5x times x is 5x. 5 times -1 is -5. And then we get equal to 15. So you see, by multiplying by the least common denominator, like we did fraction busting earlier in the year, it's going to cancel everything out in the denominator. It's just extra useful now, so we don't have any like expressions in the denominator. It actually makes it super nice. Instead of just canceling numbers, we're canceling like entire expressions, which is super nice, okay? All right, now we need to combine like terms. So we have 5x and 5x is 10x. Minus 5 equals 15. Then I'm going to solve for x. I'm going to add 5 to both sides to get 10x equals 20. Divide by 2, or 10, to get x equals 2. All right. Now we need to check for extraneous solutions. So I'm going to plug in 2 into the original equation. So I'm going to have 5 times 2 over 2 minus 1 plus 5 equals 15 over 2 minus 1. Okay, we're checking for extraneous solutions. Make sure that it's an actual solution, not extraneous solution. So we have 10 over 1 plus 5 over 1 equals 15 over 1. Well, what's 10 plus 5? We have a common denominator. Does 15 equal 15? So this is going to be x equals 2 is going to be a solution and not an extraneous solution. All right, sounds good. Why don't you see if you can try, I don't know, see if you can try number 2 or 3 or 4. See if you can do any of these if you feel like you got a good grasp on it. Otherwise, we'll go over a couple more examples in a second here. All right, let's try number 2. Number 2, we have 7 over x plus 3 over 4 equals 5 over x. So, can we factor any of the denominators here or no? We cannot. Now we need to find a least common denominator, which is going to equal what? Well, we have, I see a 4 down there, and I also see an x. We need to multiply by 4 and x. Those are all the factors that we have down there, okay? So now we're going to multiply every term by 4x. Put it over 1. Okay, so now what's going to cancel here? Well, I see I have x and x over here. I see I have 4 and 4, and I see I have x and x over here. So now I'm going to have 4 times 7, which is 28, plus 3 times x, which is going to be 3x, equals then 5 times 4, which is going to be 20. Solving for x now I need to subtract 28 from both sides, so I'm going to get 3x equals negative 8. Divide by 3, I'm going to get x equals negative 8/3. And this is our answer. If you were to plug this into your calculator, you should get negative 1.875. To check for extraneous solutions equals, here, I'm going to write out the steps. Sorry, I kind of goofed up here. So it's if we write out the steps, it's going to be 7 over negative 8/3 plus 3/4 equals 5 over negative 8/3. That's going to be negative 1.875 equals negative 1.875. So that is good. So that actually is an answer and not an extraneous solution. Okay? If you need some help reducing those fractions or solving those, make sure you talk to me in person. I'm not going to spend too much time on that today. Okay? All right. See if you can try 3 and 4 if you haven't already. Otherwise, we'll go through them in a second here. All right, number 3 is a little tricky. We have x over x plus 3 plus 1 over x minus 3 equals 1. Now, are x plus 3 and x minus 3 the same factors or no? And also, can we do any factoring here? No factoring. We can't do any factoring. So we need to find a least common denominator. Now, what is the least common denominator here? Is it just x plus 3 or x minus 3? These are actually different factors. Even though they look very similar, they are different factors. We have to multiply by both. That is the least common denominator is x plus 3 times x minus 3. Okay? This one's going to be a little bit longer. We're going to do x plus 3 times x minus 3 times x over x plus 3 plus, then we're going to do x plus 3 times x minus 3 times 1 over x minus 3. Put this over 1 equals 1 over 1 times x plus 3 times x minus 3. Ooh, a lot of stuff going on here. Okay, so we're multiplying this. X plus 3s are going to cancel here. X minus 3s are going to cancel here. Oops, I goofed up. I canceled the x. X plus 3 is going to cancel here. X minus 3 is going to cancel here. So now we're going to do x times x minus 3, which is going to be x squared minus 3x plus, this is going to be 1 times x plus 3 is x plus 3 equals, then we're going to have x plus 3 times x minus 3 over here. Can write it out, I guess, for now. Okay. So I need to distribute over here. So we're going to combine like terms over here. So we have x squared, and then we have minus 2x plus 3 equals, then x plus 3 times x minus 3 is the difference of squares. It's going to be x squared minus 9. All right, now we solve by subtracting x squared from both sides. So we get negative 2x plus 3 equals negative 9. Solve for x now by subtracting 3. Negative 2x equals negative 12. and then divide by -2, we're going to get x equals 6. Okay? If we plug it into our original equation, we're going to have 6 over 6 plus 3 plus 1 over 6 minus 3 equals 1. Well, that's going to be 6 over 9 plus 1 over 3 equals 1. And that's 2/3 plus 1/3 equals 1. Does 2/3 plus 1/3 equal 1? It does. It reduces 6/9. So x equals 6 is going to be an actual solution. All right, last one for this section. Okay, number 4. First things first, we have 10 over x squared minus 4 equals 1 minus x over 1 over x plus 1. Sorry, I butchered that pretty bad. Anything to factor here? Yes, we can factor this part right here. This x squared minus 4 is going to be x plus 2 times x minus 2. So what is our least common denominator here? Our least common denominator is going to equal, well, we have x plus, this one has 1x plus 2, but we have x plus 2 times x minus 2 is going to be our least common denominator. There we go. So we're going to multiply everything by that. So we're going to do 10, we're going to do x plus 2, x minus 2 over 1 times 10 over x plus 2, x minus 2 equals, that's 10, there we go, 1 over 1 over 1, 1 over 1 times x plus 2 times x minus 2 over 1, and then minus, we're going to do 1 over 1 times x plus 2, x minus 2. I got to use a different color here. We'll just go like this. This is x plus 2 times x minus 2 over here, all on the top. Okay? So these are going to cancel. X plus 2s are going to cancel. X minus 2 is going to cancel. And yeah, something's goofy here. Oh, down here is x minus 2. I goofed something up. So down here should have been 1 over x plus 2. So the x plus 2s are going to cancel over here. We're going to have x minus 2. So now we have 10 equals, and then x plus 2 times x minus 2 is x squared minus 4. That's this right up here. Minus, and then we got to do, it's -1. Over here is -1 times x minus 2, right? So that's going to be minus x plus 2. Okay? All right, and then if we combine like terms, -4 and 2, we're going to get 10 equals x squared minus x minus 2. Subtract 10 from both sides to make it equal to 0 to solve a quadratic. X squared minus x minus 12. This factors 2. How does it factor? So basically we set it equal to 0 because it's a quadratic. It's a squared. It's going to factor 2. It's going to be x minus 4 times x plus 3. So x is going to be equal to 4 or -3. Then if you check both of these, we're kind of out of room over here, but if you check them, they're both going to work. This is going to work, and this is going to work. You plug these into the original problems. There's no extraneous solutions here. Okay. All right, I think we got one more example here. Yep, just one more example. All right, sounds good. Choose a different color. So it says you can still fraction bust. Should solve if each side of the equation is a single rational expression. All right, so let's rewrite this. We have 2x over x plus 3 equals 3x over x minus 3. So 2x over x plus 3 equals 3x over x minus 3. All right, so we need to go ahead and find our least common denominator here, which is going to be what? Well, we have x plus 3 and x minus 3. Those are the two factors there. So we're going to multiply both sides by x plus 3, x minus 3, and over here by x plus 3 times x minus 3. Okay, x plus 3s are going to cancel over here. X minus 3 is going to cancel over here. So you can see now we have 2x times x minus 3, which which is going to be 2x squared minus 6x. That's going to equal, over here we have 3x times both of these, which is going to be 3x squared plus 9x. All right, so now we have another quadratic, so we want to make it equal to 0, so I'm going to add 6x to both sides. Now I'm going to subtract 2x squared from both sides. So we're going to get 0 equals x squared plus 15x. If we factor this by GCF, we're going to get 0 equals x times x plus 15. And then our answer is going to be x equals 0 or negative 15. And if you check these, they're actually all going to work. So we had no extraneous solutions for all these problems here, okay? All right, and that is how you solve rational equations. You're just doing a lot of fraction busting and finding common denominators, and you're good to go. Thank you for watching. Have a great day, and we will talk soon.